Hey folks, so today I want to show you a visually intuitive way to do Bayes' rule problems. This one came off the Wikipedia page for posterior probability, and it's that you have a school where there are 40% girls, 60% boys, 50% of the girls wear pants, and 100% of the boys wear pants. The question is, given that we've seen someone who's wearing pants, what's the probability that they are a girl? Also known as the probability of girl given pants. So here you see the conventional Bayes' rule formula that you'd see in a textbook. You may have also seen it written this way. But what I'm going to do instead is draw a square that represents a probability space of 1. And I'm going to split it up 40-60. So this side is going to be the girls, and this side is going to be boys, also known as girl complement. And if you've never seen that notation, the complement of something just means not something. So the probability that a person is a girl plus the probability that the person is not a girl should sum up to 1. And that makes sense, right? A person is either a girl or a boy with 40% or 60% probability respectively. And to make it clear that this side is girls, I'm going to sort of shade it in with this pink color here. So now I'm going to do the pants split. We know that 50% of the girls wear pants. I'm going to take this pink area and split it up 50-50. And I'll just randomly pick the bottom to be blue. Okay, and I'm just going to make it really clear that that blue here is pants. And then 100% of the boys wear pants, so 100% of this area here is also going to be blue. And that is pants. Okay, so we're looking for the probability, given that we saw pants, a person is a girl. And before we had any information about a specific instance of a person wearing pants, if you had to guess whether or not a random person was a girl or a boy, you'd use this whole square, right? So if I just asked you, before you saw anyone's clothes, what's the probability that a person is a girl at this school, you would just say 40%, because that's all you have to go on. That's all the information that you have. So that's prior to us being given any information about the pants, you'd use this 40% probability here. But now that we've been given some evidence, right, we've been given these pants here, we will no longer be using this whole square to represent that person. Instead, what we will be using is the part of the square remaining that is still possible, given the evidence that we've seen, which is what I'm outlining in red right now. So this is sort of the key idea of Bayes' rule, right? Before you're given any evidence, you start out with some knowledge of the distribution of the whole population, right? In this case, it's that we have this 40% girls and this 60% boys. But as soon as we're given a piece of evidence, as soon as we see pants, we have to now cut out a section of this probability space, and that's sort of this yellow area that I'm outlining here. Given that we've seen someone wearing pants, we know that that person can no longer sit in this space, so to speak, because everyone in this space is a girl who is not wearing pants, and we know that we've seen someone who wears pants. So, probability that it's a girl, given that we've seen pants, is going to be something over something. And in the denominator, we're going to put the probability space that we have left. So everything that is still possible, which is going to be this backward sort of L-shaped space here, right? And this is everything that's possible. It's either a girl who's wearing pants or it's a boy who's wearing pants, but it certainly can't be a girl who's not wearing pants. And then what do we put in the numerator? Well, given that we're operating now in this backwards L-shaped space, how much of this space represents people who are girls? Well, it's just going to be this pink area here, right? It's the overlap of the pink area with the blue area. So I'm going to outline that in green here, and I'll put that here. So this doesn't look like your conventional Bayes rule formula, but this is numerically correct. If you were to now take these shapes and map them to numbers, you'd get the correct answer. So I'll do that with you right now. What does that equal? Well, so the green is how much of this pink area, right? Well, it's half of the pink area because we know that 50% of girls wear pants. So I'm just going to write this out sort of as an intermediate step, 0.5 times, actually it's this It's this tall pink rectangle here. And then that gets divided by, well, let's split this red area up, right? We have this green over here on this side, and we're going to add that to this big blue boy area here. So that's going to be this big, tall area that's colored in like that. So let's go through one more time and turn these to numbers. So the top is 0.5 times, well, what's the pink area? The pink area is just the portion of the population that's girls, so that's 0.4. And then on the bottom, we have the green. We've already calculated the green on top, right? So that's 0.5 times 0.4 again, plus this blue area here, well, what is that? It's the portion of the population that is boys, and then 100% of them wear pants. So we take all of it. So that's plus 0.6 times 1. And then if we do all of that out, 0.5 times 0.4 is 0.2 over, that's the same thing, 0.2 plus 0.6 equals 0.2 over 0.8 equals 1/4. And that is the correct answer. If you check the Wikipedia page for posterior probability, you'll see that's the answer to this question. And I'm going to argue that what I did here with all these shapes is exactly the same as what Bayes' rule is telling us. Let's go through and sort of look at that. So what is it that we have? Well, let's look at the prior first, right? Let's look at this idea of a prior. That's this here. It's just the probability that someone's a girl, period, right? Like prior to us seeing a specific person who's wearing pants, if I had to guess the probability that someone is a girl, I'm just going off the population, right? That's this kind of pink area here. But once we are given some evidence, and what is that evidence? The evidence is that someone's wearing pants, right? We have evidence, oops, use the blue color here. We have evidence. That's the probability that someone is wearing pants, period. And that corresponds to this kind of L-shaped space here. And that makes sense because this L-shaped space represents the portion of the entire probability space where someone is wearing pants. It's all of the boys wearing pants plus all of the girls who are wearing pants. So that's why we call that bottom portion evidence. And then this here, the likelihood, well, once we've seen some evidence, we need to adjust our prior given the information that we've seen. So we saw pants. That means that we want to remove all of the girls who are not wearing pants. We need to adjust this prior that we had. So we remove that by taking out this top yellow portion here. And we have what's left, well, 50% of the girls wear pants. So we now only have 50% of those girls left who can still be people who are wearing pants, right? Given that we've seen pants. So that's why we use this likelihood up here, this probability that given it's a girl, is she going to be wearing pants? That's our 50%, so that's why that slots in. So yeah, I hope that helped give you a little bit of the intuition behind Bayes' rule. And if anything was unclear, feel free to let me know down in the comments. And yeah, thanks for watching.